Welcome, dear students. Today our lecture is about water pollution reduction. Last time we talked about conservation. Then that we talked about energy conservation. We are gradually heading towards our more specific issues which we are facing in our environment and in our organizations. So, leading from the basics like why we need energy conservation, what can be the possibilities of energy conservation, other alternatives in response to our so expensive fossil fuel, their maintenance and their environmental hazard, what we can do and what are the options available. Similarly, talking about water conservation, in which we talked about water availability, the resources, and then we talked how water can be conserved, how water can be saved. Now we will be talking about water pollution reduction. What it actually means, water pollution reduction. Now we are talking that all kinds of pollutants which once enters into our water bodies, how we can reduce that load. And in our initial lectures, we talked that our main focus is overall the reduction of load. We don't want pollutants to be present in our system because it's difficult to get rid of the pollutants. Once they enter into the system, it's difficult to eradicate their presence. We cannot eliminate these uh, pollutants from the system because now most of the chemicals are non-biodegradable. They sustain in the system for such a long duration. To if you consider the example of CFC, methyl bromides, and persistent organic pollutants, and polyphenols, dioxins, freons, all these are non-biodegradable and they are extensively available in our system, in our environment. They sustain there and they travel to longer distances. And these are the sources of our ozone layer depletion, leading to global warming and then to our climate change. And then the whole system is disturbed, our environmental systems are disturbed because of these unwanted changes in our climate. So what's the point here that we overall need reduction in our pollution load? This is something we find in our first lecture. Now we are trying to explore means and modes how we can actually gain this, we can obtain these targets. So these are the topics which are concerned with our water pollution load. And if you see that it is quite a variety. So starting from the water streams and then separating units and then adsorbents, then membrane processes and using the separation process. So we have a variety of topics in this lecture. Starting with the first headline will be water streams. How we can reduce the load in our water streams. Ultimately, any kind of effluent, once disposed into the environment, is going to lead to our water bodies, to the drains, into the rivers, canals, wherever we have linked them. And even if you consider them in our treatment plants, we are still collecting it as a sludge, and that sludge is again disposed openly. So, in one way or the other, the contaminant is there. We need to. There are the range of strategies available, which we need to focus how we can address this issue, how we can actually reduce and decrease the pollutant in our water streams. So please have a look at it. So first of all, we can have a change of raw material and support material chemical. This is something which is the most beneficial because our main source of pollutant is the chemicals which are used as a raw material, and then that chemical is not consumed within the process, but it is disposed as a byproduct, an unwanted waste which is again going to exist in the system and then create problems. And then supporting chemicals, of course, also problematic. And how good it could be if we can replace these materials, raw materials and supporting chemicals. We can have some alternatives. We talked earlier that, for example, if talking about tannery waste, what are the main raw materials being used? What are the chemicals being used in the finishing of the uh, flesh skin? Sulfate, salt, which is used. So how if we replace this? अगर आप chromium sulfate salt को replace करते हैं with some other option which is more cleaner, leading to our cleaner production system, which is concerned about green engineering, green chemistry, then all the negative impact with hazardous impact on the system will be reduced. So let's focus on the exchange of raw material and support chemicals with those chemicals and raw materials which are environmentally safe. This is one of the possibilities. So, talking about the strategies to reduce the pollution load, the first thing comes in our way is to change the raw material and the supporting chemical. We need new one. We need alternatives. We need substitution. Modifying the process is another option. How we can do this by changing the process, make the process rather than using so much energy, so much water, and try to have something recirculated. Let's have the process water used within the industry to be recirculated, and then modifying the equipment. If we have a better uh, designed equipment, maybe we can reduce the demand of water in the system. As we studied earlier, अगर पानी का volume is less reduced, then what will happen? We will have a much lesser uh, effluent to treat. So it will be again beneficial for our water bodies and for our treatment plants. Improved process control, reliability of operations. So maybe if by adopting better control measures, we can avoid so many extra water usage or uh, excessive water demand can be reduced. Avoiding accidental spillage, we need some proper maintenance by the help of which we can do most of the water savings. So separation and extraction of byproducts is another option by which we can recirculate the water, reuse the water within the system. Equalization of wastewater flow. Again, it's the option in which we are going to have a more buffered uh, characterizations, so in which all the parameters will be balanced because we are collecting the wastewater continuously of different natures, so that is going to have an impact on the characteristics of the wastewater as an effluent from that tank. We will discuss it later. Choice of products and the product design. We can have the option of changing the product because want from the product, we want the required function. What if we can obtain that function by having a much safer product, then it's a better option. So let's talk about these options in detail in our coming lecture, coming slide. So now again talking about the range. So reduction of pollutants in the water stream is the target, and it is required to reduce the impact. And then recirculation of water, processed water particularly, and then to reduce the byproducts and to save input resources. Long-term goal is to eliminate to or reduce pollutants as much possible, and then lower the amount of produced pollutants, and again by reducing the raw material lead to savings as well. And then we will have lesser resource material will be required, and then lesser water volume will be required, and lesser need for the treatment if we obtain our goal. Reduce water flows, and then reduce water consumption, decrease in water pollution release. This was the target which we talked earlier. So this is something about the exchange of raw material and support chemical to trace the organic or origin of pollutants. So we need to find out what's the origin of the pollutants, from where they are coming. For example, if there is chromium in our drain, canal or river, then let's trace it back from where it is coming. Is there any leather industry, tanning industry, or there is electroplating industry? From where this chromium is coming? Reduce in the raw material, as we talked. There is an option that we should focus on reducing the raw material consumption, and it can lead to exchange of raw material, contributing materials by higher quality materials, and then the reduction of acid rain by using low sulfur oil for heating, and this is one of the possibility we achieve our goal. And then, for example, chlorine-based bleaching process in paper and pulp industry, which is resulting in the release of toxic chlorinated hydrocarbons. It can be exchanged with other bleaching chemicals. Other bleaching chemicals will be like oxygen, chlorine dioxide, or ozone, hydrogen peroxide used in combination. So there can be different combinations, but this is one of the options how we can get rid of this bleaching process, chlorine usage in bleaching process in paper and pulp industry, which is resulting in the release of toxic chlorinated hydrocarbons. This is one of the options. Here you can go through it in detail, and you can find how this is going to help in our industry, paper and pulp industry. Then modifying of the process is one of the options, and then in this case optimizing the process by finding best temperature, time, concentration of reactants. So this the process is of course have some requirement, which is like temperature, like oxygen, like uh, other chemical characterizations. If we get a more optimized process, and we are concerned about these parameters, so we only focus on obtaining these parameters. So install equipment for process control, that is through online measurement of component in the process and proper feedback mechanism. So there are different other means by which we can achieve it, by altering the reaction time, temperature, pressure, chemical environment in the process, increase the yield by, for instance, improved technology, install internal cleaning steps, for instance, for separation of pollutants from the process, recover input chemical and recirculate them back to the process, reuse input chemical for purposes with lower quality demand, improve the handling of raw storage, change the process to an entirely new way of manufacturing the product. So these are the options. how we can modify the process. And what we will be getting maybe in some cases completely different product. Maybe we are going to have better optimization. So these are the possibilities. This is another example, like in textile chain, we are normally disposing highly polluted waste from these processes. And uh, starch had been traditionally used as a sizing agent for weaving, and this starch, after hydrolysis removal, was the source of 30 to 50% of emission of oxygen demand matters. UD-COD level oil wastewater are higher because of the use of this starch, and this starch is used for the purpose of sizing in different processes of textile. Now, um, um, because BOD and COD levels are increasing, the industry began to express an interest in cellulose-based sizing agent, which would exhibit little or no BOD or toxic effects in recipients. So this is the changing of modification in the process. We are actually completely changing this process of uh, uh, these desizing and sizing and clearing and dyeing. All these processes will be changed when we are going to change the basic product which is used in this process. So another option, coal mining company used the public water supply to wash the raw coal. At the same time, a second waste stream was the acid mine wastewater. So we are having this wastewater and this wastewater both. Now the company modified its process and washed raw coal with acid mine wastewater. Now this wastewater is being used to clean this raw coal, and the earlier water supply is now no more required in this case. Thus, the mine drainage was neutralized with the coal while the coal was washed free from the impurities. This is an option while we talk about the modification in the process. Now, modification in the equipment. Optimizing, modernizing of equipment help in reducing amount of pollutants. So what kind of modernization and optimization we can add? It is in the form of filters, mechanical devices for separation of waste from a stream. So illustrating an example or found in the food industry, when where we have fragments, of course we have fragments of different kinds of foods and vegetables, like cucumbers which were disposed along with the waste stream. And so what we did, we added up a screen, and then because of the screening uh, over the drain lines, the most of the food waste was not allowed to escape along with the effluent into the water bodies. So we separated the solid waste of this food, and we uh, disposed of this food waste separately. So what happened? It reduced the waste load in the waste stream drains. Another thing we did, like in the poultry plant, pieces of feather and fat were found in wastewater. So traps on the discharge pipelines helped in removing these waste products, and we dispose them separately. And again, the removal of fibers from wastewater streams in factories by simply adding filters is another example in this case. So this is something about the modifying the equipment. Now, improved process control, reliability of the operations. Within the metal surface treatment industry, breakdown and process disruptions count for about 80% of the total amount of pollutants emitted. So, in this case, if we properly control the process, we maintain the electric supply and we maintain the monitoring and we uh, not allow the emissions to be produced in this metal surface treatment industry. In this case, we will be going to obtain much more stability in the effluent. So this was another option. Now, avoiding the accidental spills. What happens that when we don't have a proper maintenance and there are some operational uh, mismanagement issues, what happens? Most of the waste is leaked out and disposed at wrong places where it cannot be properly collected and it cannot be properly recirculated or processed or treated. Thus, what happens? Wastewater is going to get um, uh, uh, is going to remain at the places where it should not be present. We are actually wasting the flow because of this mismanagement. So, um, many accidental discharges are usually small in volume and go unobserved. One therefore needs to pay special attention to them, even if it is almost impossible to prevent every potential accident from occurring. There are some measures that can be taken to reduce the likelihood of accidents and severity and if they occur. Some suggestions are as follows. So make certain that all pipelines are clearly marked for identification. Allow only certain designated and skilled persons to operate. Install indicators and warning systems for leak and spills. Provide for detention of spilled wastewater in holding basins or lagoons until proper waste treatment can be accomplished. Monitor all the effluent quantity quality to provide a positive public record. If necessary, establish a regular maintenance program of all the pollution treatment equipment and all production equipment which may result in a liquid discharge to the sewer networks. Now, separation and extraction of byproduct. There is a lot of room and space in these processes. We have different options based on the nature of the wastewater. So, what kind of pollutants there are, we can adopt different techniques. Wastewater treatment cost can be reduced by keeping the different kinds of wastewater separate. This is we talked earlier as well that if different sources of wastewater are separated, we need different kinds of treatment. Sometimes maybe we don't even need treatment if we separate the uh, wastewater coming from different sources. Please understand this. So separate treatment processes for different kinds of wastewater help in reducing the cost of treatment. It's obvious. Simple treatment techniques and extraction process can be adopted. One simple example is from the metallurgy industry. Metal plating industry use ion exchangers to recover phosphoric acid, copper, nickel, chromium from plating solutions. The deionized water from the ion exchangers without any further treatment is ideal for boiler feed requirements. Solutions received from the regeneration of the ion exchanger resins, now with high content of metal ions, can either be recycled in the metal plating process or used for recovery of valuable metallic or nickel. So we are also interested in recovering the valuable metallic compounds. It can be chromium, copper, and nickel, and these recovered material will be again used as raw material, input material. So this is the example. So equalization of wastewater flow, a very simple and interesting feature. Industries with several products from different processes often prefer to level out their wastewater. This means that the wastewater is collected in a surge tank during a certain period, depending on the turnout time for the different processes in the industry. For instance, a product is produced in number of steps, taking in total 8 hours. The surge tank must have a residence time of at least 8 hours. The wastewater flow from this tank will have more even composition and characteristics compared to the inflow to the tank. The goal with leveling out the wastewater is to achieve a stabilization of, among other things, pH, purity in wastewater. At the same time, the tank also serves as a sedimentation tank for separation of particles. Stabilized wastewater can be treated more readily and efficiently in industrial and municipal cleaning plant. So in some cases, leveling will make other treatments unnecessary. This is the case, for instance, if pH varies heavily with time. Now let's see the graph. This graph, if you see that we have a surge tank and there is a continuous inflow with varying characteristics. We are only considering pH. See how the pH level is varying with time. So this is the time duration and this is the change of pH. So we have a different pH level after every specific time interval. What will happen that if uh, this water coming in is allowed to leave the tank in a shorter duration, and we are directly connecting the inflow to the outflow, and we are not allowing the water to neutralize, then we will need to treat different kinds of pH. pH जो है वो बहुत तेजी के साथ चेंज हो रही है. हमें हर pH के लिए जो ट्रीटमेंट है वो प्रोवाइड करनी पड़ेगी. Sometimes it is so less pH and sometimes it is up to 9 pH, maybe to 10 pH. सो ये जो चेंज है एसिडिक नेचर से बेसिक नेचर की तरफ इसकी इसकी वजह से हमें जो ट्रीटमेंट मेथड है वो बहुत तेजी के साथ चेंज करना पड़ेगा. लेकिन इस सर्च टैंक का प्लस पॉइंट क्या है? वी आर कंटिन्यूसली एडिंग अप द वेस्ट वाटर. अब एडिंग अप होने की वजह से the wastewater which was initially adding उसकी pH was about 2, then after some hours we got pH up to 8, 9, 10, and then again back to 2, 4, 3, and then again higher up to 8, and then back to 4, and then back to 8. अब इन सब pH का आपस में continuously एक ही जगह पे exist करना is going to stabilize the pH. यहाँ से जो pH बाहर जाएगी आफ्टर दिस टाइम ड्यूरेशन इट विल बी मच मोर स्टेबलाइज्ड. अगर हम फौरन इसके बाद वाटर को अलाउ कर रिलीज करना and we take it to some treatment plant, we will have to provide different treatments for basic separately, acidic separately. But in this case, you see there is a stabilization. So we need only one type of treatment. So this is something which we can adopt. So what we are doing, we are actually equalization of effluent. And we have an equalization tank. If you recall your wastewater course, it is a tank which is provided next to preliminary treatment. और उसका बेसिक मकसद जो है, इट इज़ नॉट ओनली फॉर सेडिमेंटेशन बट आल्सो इक्वलाइजेशन। हम चाह रहे हैं कि जो जितनी भी करेक्टरिस्टिक्स आ रहे हैं वो होमोजेनाइज करें। दे शुड बी सिंगल there should be single characteristics of one parameter like pH, like TDS, like TSS, like sludge, like organic matter. So, like other metals, inorganics, everything should be stabilized and then it should be passed on to the next phase of the treatment. So choice of the product and product design. You see here, again, if a certain product required process that gives rise to a large wastewater streams, one may reconsider the product itself. So in this case, जैसे कि we have a paint and have been one solution. For example, cadmium containing paints were outlawed at some point, replaced by other paints. So इस तरह की जो modifications हैं product में that can be adopted in cases when it seems difficult to modify the product, then different approach may be needed and analysis of the function of the product can sometimes suggest that there are other ways to fulfill the function. So uh, now we have some separation unit operations for cleaner production. Separation means we need to recover some. हमारा जो एफर्ट है उसके अंदर बहुत सारे बाय प्रोडक्ट्स जो कि हमें जो कि यूज नहीं हुए, दे वर ओनली हेल्पिंग वर्क एज अ कैटलिस्ट। सो व्हाट हैपेंस, वी नीड टू रिकवर, हमने उनको रिकवर करना है एंड देन वी विल बी रीयूजिंग दोज प्रोडक्ट्स एज अ रॉ मटेरियल, एज एन इनफ्लो मटेरियल। सो उसके लिए प्रोसेसेस कौन से हैं? वी हैव adsorbents, we have activated carbons, polymer adsorbents, molecular sieve, silica gel, and ion exchange is the process. Membrane separation is another technique. Extraction is another technique. Stripping is another technique. So I will request you, please go to chapter in the book I have recommended. उसमें ये सारे बहुत ही डिटेल के अंदर एक्सप्लेन किए गए। I wish you to go through them thoroughly and understand all the processes in detail कि हम यहाँ पे नहीं cover कर पाएंगे। But I will request you कि आप please इनको thoroughly करें from the book because it's very important to understand कि absorption process जो है वो कैसे होगा, उसमें ये सारी चीज़ें जो है वो involve हैं। And then we have an ion exchange method, उसकी क्या application है, membrane separation कब use करते हैं, extraction कब करेंगे, and कब adopt करेंगे, and then activity is also one of the techniques. And then in this we can go further, choosing separation process, treatment process for different water streams. Which method is right? Column or batch separation. तो ये वो टेक्निक्स हैं कि हमने अडॉप्ट करनी है, कैसे अडॉप्ट करेंगे। नाउ वी आर गोइंग टू चूज सेपरेशन प्रोसेस, उसको हमने इन तीन हेडिंग्स में स्टडी करना है। सेपरेशन ट्रीटमेंट प्रोसेस फॉर डिफरेंट वेस्ट वाटर स्ट्रीम्स। सो इसमें ये है कि फॉर सोफिस्टिकेटेड एडजॉर्प्शन मेथड, more sophisticated absorption methods are used for processed water, where the volumes may not be so large and value of recycling water because of the components used in the process. So there are different approaches which we can adopt depending upon the nature of wastewater. So in this case we are talking about the processed water. उसके लिए हम ज़्यादा sophisticated adsorption method को adopt कर सकते हैं क्योंकि उसमें हमारा जो volume of water है ज़्यादा नहीं होगा and the value of recycling is high and so we can get a finer quality of water. उसके लिए finer sophisticated adsorption method है वो adopt किया जा सकता है. Which method is right? So property of the substance to be removed uh, is the thumb rule to define uh, the method. So जैसे कि adsorption with activated carbon used as a polishing step, excellent for separation for organic compounds at low concentration. So concentration low, we can adopt activated carbon. And adsorption with polymer adsorbents is used for recovery of organic compounds at higher concentrations. And then ion exchange is used for ionic substances at low concentration. एक्सट्रैक्शन जो है उसको हम यूज कर सकते हैं फॉर हाइड्रोफोबिक ऑर्गेनिक सब्सटेंसेस at high concentration. Stripping is used for separation of volatile, often non-degradable substances at low to high concentrations. For comparatively large molecules, membrane separation is often selected. A special case is used for electrolysis for separation of ionic substances, more complex water solution, low to uh, high concentration. Please, I will request कि please इनको go through करें and try to memorize because it's very important कि कौन सा method जो है separation का that is feasible under what कौन सी conditions जो हैं जो कि अगर exist करेंगी तो हम कौन सी जो technique है उसको prefer करेंगे. Please इसको thoroughly go through. Then we have column or batch wise separation. इसमें I think it's quite simple कि continuous operation जो है are designed to be operated for 24 hours a day, 7 days a week, throughout the year. Some downtime will be allowed for maintenance, but mainly it is a continuous process. So batch processes are designed to operate intermittently, जिसमें कि वो जो है वो after some time, specific time, it has to stop, and then we need a new feed of wastewater flowing into it, and then we treat it, and then we carry it forward. Continuous process will usually be more economical. इसका सबसे बेस्ट जो है वो वेस्ट वाटर में है जबकि हमारे पास क्वालिटी ऑफ वेस्ट वाटर जो है वो वेरी करती हुई होती है सो उसमें हमें एक बफर जोन मिलता है एक इक्वलाइजेशन का टाइम मिलता है इन कंटिन्यूस प्रोसेसिंग तो इसको हम इस तरह से भी प्रेफर करते हैं so this is something about it please go through it and I will request you to uh, thoroughly go through chapter number 8 of the book which I have recommended इसकी जो proper समझ है वो आए and uh, here for any more of the questions. Thank you so much for today's lecture.